Hello everyone, I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to have a discussion on basic tie-set matrix and its related problems. So first, what are the matrix? So first, in the last lecture, we discussed about incidence matrix, and in this lecture, I will explain about fundamental loop matrix. That means basic tie-set matrix, loop matrix, and next cut set matrix. These are the three matrix. Incident matrix is represented with capital A, and tie set matrix, loop matrix is represented with capital B, and cut set matrix is represented with capital C. Incidence matrix is number of rows cross number of rows means here number of nodes cross number of branches. Here number of loops cross number of branches. And here number of F-cut sets, that means number of twigs in a tree, and F-cut sets cross number of branches. The order of the incident matrix is N by B, and order of the fundamental loop cut set, the loop matrix is basic tie set matrix is L cross B, and fundamental F-cut set matrix C order is F cross B. Now this one we discussed in the last lecture. In this lecture, I will explain about this fundamental loop matrix, that means basic tie set matrix. So first, basic tie set matrix, we can call it as F loop also. F indicates fundamental. Fundamental loop is a loop which contains only links and more one link. It consists of one link and one or more twigs. It consists of, so a loop may consist of one or more twigs. Suppose this is the one graph. In this is the one loop. In this, it may be one link. Remaining branches are twigs. So twigs may be one or more, 1, 2, 3, and link should be 1. So that is the loop. And second one, so here the number of F loops will be equals to number of links. Here, number of loops equals to number of links. Possible number of loops equals to possible number of links, and the fundamental loop matrix is represented with capital B. In the previous slide, I have given the letter B for fundamental loop matrix. And next, it is also called fundamental circuit matrix. Another name, F loop, fundamental loop, fundamental circuit matrix, and tie set matrix. And this matrix gives the relation between number of branch currents and number of link currents. So number of links cross number of branches, number of loops also. Loop current means link current. If there are n number of nodes and b number of branches are present in the directed graph, that means in the oriented graph, so b number of branches, and the number of links present in the core tree. So there may be a formula. So for that number of links means that number of loops equals to b minus n plus 1. Here b indicates the branches in the oriented graph, and n indicates the nodes, number of nodes in the oriented graph, and plus 1, b minus n plus 1. Now here the number of rows, the order of the matrix B equals to number of links cross number of branches. Here links equals to B minus N plus 1. Here number of rows are B minus N plus 1. Fundamental loop matrix, that means tie set matrix, will have B minus N plus 1 rows and B number of columns, number of branches or columns. Here rows and columns are corresponding to the links of the core tree and branches of the given graph. Hence, the order of the fundamental loop matrix is B minus N plus 1 cross B. This one. Now, so procedure to find out the fundamental loop matrix, that means tie set matrix. What are the steps? So here we have 3 steps. First, select a tree of given directed graph. Directed graph means in the oriented graph, first select any one of the tree. So by including one tree, suppose this is the directed graph. If it is having this one, this is one. Select one tree, first one. This is the tree. Tree means there is no closed loop which consists of the graph. In this graph, the graph should not consist of any closed path, and all number should consist of all number of nodes. It consists of all number of nodes, and there is no closed path, there is no link. Now these are the links. So now including links at a time, we will get the F loop. So now if you add the links, we will get the F loops. So now here these are the loops. So 1, 2 and 3. So including one link at a time, we will get one F loop and fill the all values, all the elements of corresponding to this F loop in the row. So these elements in the incident in the tie set matrix, I will explain in the next slide. Okay, so what are the, so in the B matrix, elements are +1, -1 and 0. So that +1, -1 and 0, if it is same direction, if that loop current direction is always clockwise direction, and that loop current direction and this branch direction is same direction, that is +1. If it is opposite direction, that is -1, and that the branch current is not associated with that loop current, then that value is 0. And repeat this above 2 steps for all links. So here these are the steps. Select any one of the tree by including one link, and by including one link, we will get one F loop. So here fill all the elements in the matrix and repeat the above step for all links. And next, so elements, how you will fill the elements in the basic tie set matrix. So first, elements in the tie set matrix, so that elements are +1 and -1 and 0. So value is 0. When it will be 0, so the twig link and twig directions are not associated, which are not part of the selected F loop. And here if it is a +1, so the direction of twig and selected loop is same direction, and this F link direction is same. This one is important. If it is same, +1. If it is not a part of F selected F cut set F loop, and that is 0. And if it is opposite, same thing here. This is the opposite, same this one and this one. If it is opposite direction, -1. If it is same direction, +1. And if it is not associated, not a part of the selected loop, then that value is 0. 0, +1 and -1. Now, let us take one example. First, this is the graph. Here possible number of loops in a given graph, 1 and 2. So for this particular graph, determine basic tie set matrix. So basic tie set matrix order here for this particular graph. So now here, so first select what are the steps to get to find out the basic tie set matrix. So first one is, first select any one tree. Here possible number of trees are here. So here tree should consist of here one node, A node, and this is the B node. A node and B node. This is A and this is B, this is A, and this is B. This tree consists of only one branch. This is twig, and remaining elements are second step and links. Possible number of loops, F loops here, 1 and 2. Now here the matrix size, so number of branches here, 3, and number of nodes here 2, and number of links L equals to 3 minus 2 plus 1, that equals to 2 number of F loops, and 2 number of loops only, 2 number of links. From the formula also it is satisfied. So now 2 number of links. So link 1 or loop 1, loop current direction, and this is the loop 2 or link 2, and these are the number of loops or number of links and branches. So what are the branches here? 1, 2 and 3. Now fill the elements here. This matrix size is 2 cross 3, B minus N plus 1 cross and B. B indicates number of branches and N indicates number of nodes, and the L indicates the number of links, number of F loops. Now fill the elements in this matrix first. First one is, so now if it is, this direction is always clockwise direction, this is the first one and this is the second one. If this direction is same direction, then that is plus 1, and if it is opposite direction, minus 1. Here one branch and this F loop direction is same direction, this is plus 1, and 2 is opposite to this one. Here it is flowing from right to left, and it is flowing from left to right, and this one 3 is not associated with loop 1, and same way here 2 branches plus 1 for the second one, and 3 branches not associated, say opposite direction, and this one is not associated with 0. Now B matrix equals to, so plus 1 minus 1 0, and 0 plus 1 minus 1, this one 2 cross 3. This is the basic tie set matrix for this particular graph. Now second problem. For this particular network graph, determine basic tie set matrix. So now first here possible number of, what are the rows first? B equals to, what are the steps? First select any one of the tree. So I am selecting this tree, and these are the links. These are the links, and link 1, link 2 and link 3, and loop 1, loop 2 and loop 3. Now here possible number of branches, here 6 for this graph, and possible number of nodes here 4 nodes, A, B, C and D, and number of links equals to, here we got 3. So it will be verified from this formula, B minus N plus 1, that equals to 6 minus 4 plus 1, that equals to 2 plus 1 equals to 3. Now these directions are always clockwise direction, and clockwise direction. Now the matrix size is 3 cross, and that matrix B equals to 3, B matrix size is 3 cross 6. So here 1, 2, 3, 4, 5, 6 and 1, 2 and 3. So now fill the elements. So these are the branches and these are the links or loops 1, 2 and 3. This one is 1, 2, L1, L2 and L3, 1, 2, 3, 4, 5, 6. Now here the L1, this is the L1, L1 direction, 1 this direction, and if it is same direction, so it is one branch direction, this direction is same direction plus 1, and 2 direction and this one is same direction plus 1, and fourth is opposite, from the top to bottom is the F loop direction, and this bottom to top is the fourth direction, this is the -1. Remaining all elements are not associated with this first loop. And second loop, here this is the second loop. Second loop not associated elements are 1, 4, 3. So this one 1, 3, 4 are not associated. So not a part of the this F loop 2. And here 2 branch, this direction is same. 2 branch is not same direction, opposite direction. This is from this direction and this is from this direction. This is -1. And 6 direction and this F loop direction is -1, same, sorry, +1 direction, same direction, and 5 direction and this loop direction is same direction, +1. Now here third loop, this is the third loop direction. So 1, 2, 5 are not associated, and 6 is opposite and 3 is opposite, -1, -1, and fourth one direction is the +1. So now the matrix elements are +1, +1, 0, -1, 0, 0, and 0, -1, 0, 0, +1 and +1, and 0, 0, -1, +1, and 0, -1. So 1, 2, sorry. One, 2, 3, 4, and 5. So these are the 5 and 6. 6L. Next, for this graph, first for this graph determine basic tie-set matrix. So for this graph determine basic tie-set matrix means, so step 1 is select one tree. So this tree I am selecting, same thing here. These are the links. So not this 1, 2, 3. This is the not. This is not link. So first I am erasing. So first don't use this one. So use this one. This is tree. These are the links. Don't use this one. So now here the selection of tree is this one. So this is one link and this is one link So use this tree, it is better. If you selection of tree is important, if you use this one, it is better. And select another color. Let me change the color over here. This is one link, this is one link, and this is, now it is correct. This tree is important. First step 1 is select one tree, and here this is 2, this is the 1, and this is 4, and this is 3, and this is 5, and this is the 6. Now number of branches here 6, and number of nodes are 4, and number of links equals to b minus n plus 1, that equals to 6 minus 4 plus 1 equals to 3. So 3 number of links here, this is correct. Now here, so first here possible number of links 1, 2, 3, and in clockwise direction, and in clockwise direction, in clockwise direction. Now here the matrix size 3 cross 6, 1, 2, 3, and 1, 2, 3, 4, 5, and 6. Link 1, link 2, and link 3. These are the branches, and these are the loops or links. Now here this direction is first direction, and this one is same direction plus 1, 2 is same direction plus 1, and fourth direction is minus 1, and remaining all elements are 0, not associated. Now second one, so 1, 2, 5 are not associated, 1, 2, and 5 are not associated, and 6 and 6 is same direction, and 3 is the opposite direction, and 4 is same direction, so plus 1. Same direction is plus, opposite direction is minus, not associated with branch current. Branch direction is not associated, means that means 0. And here third loop, for this third loop, so fifth branch is plus 1 same direction, and 3 branches same direction plus 1. It is flowing like this, and plus 0, remaining all elements are 0. Now the matrix is B equals to plus 1, 0, minus 1, 0, 0. And next 0, 0, minus 1, plus 1, 0, plus 1, and 0, 0, and plus 1, 0, and plus 1, next 0, 3 by 6 cross 1, 2, 3, 4, 5, 6, and L1, L2, and L3. This is the basic tie set matrix for this graph. And next, for this graph, determine the basic tie set matrix. So first here determine the, assign the orientation directions. So this one, and this one. Now here possible number of nodes A, B, C, and D, and 1, 2, 3, 4, 5, and 6. Now here possible number of nodes, branches here B equals to 6, and possible number of nodes equals to 4, and possible number of links equals to 6 minus 4 plus 1 equals to 3. Now the matrix size here, so 3 cross 6, B minus n plus 1 cross B. This is important. Now here these are the branches, and these are the loops, loop 1, loop 2, and loop 3. 1, 2, 3, 4, 5, 6. Now here select one tree. I am selecting this tree. So now these are the twigs and remaining all are links. So this is the tree and these are the links. Now 3 number of links. Now here first. So first one, second one and third one. First one is associated elements are. So first one direction is same direction. This direction plus 1 plus 1 plus 1 and fourth direction is opposite direction minus 1 and this sixth direction is same direction, so plus 1. Remaining elements are not associated with this F loop. And second one 1, 6 and 5 and 1, 6 and 5 not associated. And next this fourth is same direction, this direction, and 2 is same direction, plus 1 and plus 1. Next 3 is not associated, 0, and this fifth one is opposite direction, this is plus, not associated, plus a minus 1. Next loop 3 equals to loop 3 equals to loop 3 elements are links. Here 1, 4, 2 are not associated. So 0, 2 and 4 are not associated. So this is the 3 branch and this one is same direction and this is a 5. Fifth one is also same direction plus 1 and this sixth one is same opposite direction is minus 1. Now these are the elements. So B equals to 1, 2, 3, 4, 5, 6. This is the matrix. So now here plus 1, 0, 0, minus 1, 0, 1. Next here 0 plus 1, 0 plus 1, minus 1, 0 and 0, 0 plus 1, 0 plus 1, minus 1. These are the elements. This matrix size is 3 by 6. So L1, L2 and L3. Next, determine the basic tie set matrix for this network. So A, B, C, D, E. So these are the 5 nodes and 1. So 1, 2, 3, 4, 5, 6, 7, 8. So total number of branches here 8. Total number of nodes are 5 and total number of links are B minus n plus 1, that equals to 8 minus 5 plus 1, that equals to 3 plus 1 equals to 4 number of links for this particular graph. Now here directions. If you assign this one in clockwise direction 1 and this is outside. Now this is oriented graph. Now here the matrix size is B minus n plus 1 cross B, that equals to 4 cross 8. So now these are the branches and loops 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6, 7 and 8. Total number of branches are 8. Now here loops are 1, links are 2, links are 3, 4. Loops are links. Now here this is loop 1, loop 2, loop 3 and loop 4. And here this is this link and this tree I am selecting, this cross tree I am selecting. So now remaining all are links. So now link direction, this one, this is the +1, and 5 is opposite direction -1, and 8 is same direction +1. So remaining all elements are 0. And 2 is not associated, sorry, 2 is +1 same direction, and 5 is same direction +1, and 6 is opposite direction -1, and remaining elements are 0. And for third loop, +1, third, 7 is opposite direction -1, and 6 is same direction +1, remaining elements are 0. And fourth is +1, and 8 is -1, and 7th is +1. Remaining elements are 0. This is the B matrix. This matrix size is 4 cross 8. Now, determine the basic tie set matrix for this particular graph. So now here I am selecting this tree. So these are the two links. So now say two links means, let me check the formula for B equals to n minus B, possible number of branches total 5, and possible number of nodes are A, B, C and D. So total 4. So total number of links equals to B minus n plus 1, that equals 5 minus 4 plus 1 equals to 2. Now here 2 cross 5, 1, 2, 3, 4, 5, 6, link 1, link 2. These are the links or loops, and these are the branches. So now fill the elements in the basic tie set matrix. Follow the steps. Select one tree, and this is loop 1, this is loop 2, F loop 1, direction clockwise, and this 1 is not associated, 5 is not associated, and 2 direction opposite direction, 4th direction opposite direction. Opposite direction means that is -1, and 3 direction is same direction +1. And this second one, 2 and 3 is not associated, and this 4th is same direction +1, and 5th is same direction +1, and this is also +1. One orientation is also +1. Now this one B equals to 0, -1, 1, -1, 0, +1, 0, 0, +1, and +1, L1, L2, 2 cross 8, 1, 2, 3, 4, and 5. This is the basic tie set matrix for this particular graph. Now, here for this particular graph, determine basic tie set matrix. So now possible number of nodes here, branches here 8, and possible number of nodes are A, B, C and D, and this is the E. Now here this is 5, number of nodes and number of links equals to B minus n plus 1, 8 minus 5 plus 1, that equals to 3 plus 1, that is 4. Now this is the matrix 4 cross 8, 1, 2, 3, 4, 5, 6, 7, 8, and this is L1, L2, L3 and L4 branches. Sorry, these are the loops or links, and these are the branches. Now select one tree first. So now remaining elements are or otherwise use this one. Same thing, this one. Use this one. Now this is 1, 2, sorry. You can use this one is also. So one, this is first one is okay. Now this is the 1, 2, 3 and 4, and this direction all are clockwise direction. This first one direction and this one is same direction plus 1, and this fourth direction and this one is same direction plus 1, and this 2 direction and this one is opposite direction minus 1, and remaining all elements are 0. Next, this second one 1, 2, 3, 8 are 0, and 6 one is also 0, and 4th is opposite, and 5th is plus 1 same direction, and 7th is same direction plus 1, and loop 3 direction. So 1, 4, 7 are not associated. 1, 4, 7 are not associated, and 6 and 8 are not associated, and 2 is same direction plus 1, and 5 is minus 1, and 3 is minus 1. And next, last one. So 1, 2, 0, and 4, 7, 5 are 0. 4, 7, 5 are 0, and 3 is same direction plus 1, and 8 is minus 1 direction, opposite direction, and 6 is plus 1. Next, last problem. This one. Same graph. So otherwise you can select a different tree. Now here this is this one. Same thing, possible number of branches are 8, and possible number of nodes are 6, and possible number of links are 8 minus 6 plus, so 8 minus A, B, C, D and E. This is 5. 5 plus 1 that equals to 4. So 4 plus 6 is the node. Now these are the branches and these are the nodes. L1, L2 and L3, L4, 1, 2, 3, 4, 5, 6, 7, 8. Now here, so first one 1, 2 and 3, this is the 4. So first one 1, 4, 2, 1 is plus 1 and 4th is plus 1 and 2 is minus 1, remaining all elements are 0. And next, second one 2, 3 and 5, 2 is plus 1, 2 is plus 1 and 3 is minus 1 and 5 is minus 1, remaining all elements are 0. And L3 1, 2, 0 and 4, 0, 7, 0 and 8, 0 and 6 is also 0. And next this third one for this third one, eighth one and sixth one not 0, and sixth is same direction plus 1 and 8 is opposite direction minus 1 and 3 is same direction plus 1, 5 is not associated. Next fourth one 1, 2, 3, 8 are 0. And seventh one, seventh one is plus 1 and fourth one is plus 1 minus 1 and fifth one is minus 1 and sixth one is minus 1. This is plus 1. Fifth one is same direction. Now the matrix size is 4 cross 8, not 6, 8. So B minus n plus 1. So that is 8 minus 5 plus 1, 4 cross 8 number of branches. This is the matrix. I hope all these problems are clear to you. If you still have any doubts in this, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.